Okay, and welcome to your video tutorial on multiplying and dividing indices. Today we're going to have a look at indices like we were yesterday, but we're going to look at the way in which we are able to multiply and divide, and we're going to look at index law and what that actually means. Now there's going to be a bit to work out. See what I did there? Because it's a dog working out. You are so very welcome for the lols. Anyway, let's begin. Okay. If we wish to calculate this, n to the power of 4 times n to the power of 2. When we looked at the concept of expanding the other day, another way we can break it down, like we were doing yesterday, is n times n times n times n, because that's n to the power of 4. Then there's a multiplication symbol in here. So again, it's multiplied by n times n. And then all I have to go is, okay, 1, 2, 3, 4, 5, 6. Okay, that's n to the power of 6. But I'm hoping most of you see a little bit of a pattern here. N to the power of 4 times n to the power of 2 equaling n to the power of 6. 4, 2, 6. Yeah, there's an interesting pattern. Because if we look more closely, a much simpler method is just to add the indices, since the pronumerals are the same. So we can add the indices when multiplying only if the bases are the same. So if it's x to the power of 4 times x to the power of 2, those bases are the same. And by bases, I mean the number in which the indice applies to. So these x's here. If it was times y to the power of 2, okay, I can only add the x's together. So the answer for this one would be x to the power of 6 times y to the power of 2. Because the base here is a y, to which this indice is attributed, I can't group it. So I can only add them if the bases are the same. And this is a concept and is part of index law. The same also works for dividing. So I forgot to write division when I was making this up, so I just did a dodgy division in there. But the same works for this. So if we have a to the power of 6 divided by a to the power of 4, first thing, whenever you see a division sign like that, always write it like this, like a fraction. Okay, this essentially means a times a times a times a times a times a divided by a times a times a times a. I've got 1, 2, 3, 4, 5, 6 on the top and 1, 2, 3, 4 on the bottom. That's another way I can write it. So I can write it and break it down and I would get something that looks like this here. Now, as there are 6 factors of a on the numerator and 6 factors of a on the denominator, for every a I have on the top, what I do is I cancel it with another a on the bottom. So a to the power of 6 divided by a to the power of 4. If I have an a on the top, I cancel it on the bottom. If I have an a on the top, I cancel it on the bottom. And I go on and on and on until I can't cancel anymore. Now I'm out of a's on the bottom. So it'll be 1 on the bottom essentially. And I've got a times a. Now a times a is a squared divided by 1. Now I know as soon as I have anything on 1, that's just the number divided by 1, so I simplify to a squared. I'm hoping someone has seen a pattern here. My answer is a squared. I started with a to the power of 6 divided by a to the power of 4. Gave me a to the power of 2. I'm hoping most of you have seen it's just the opposite of dividing. You'll need to write a sentence underneath this saying, well, when I'm dividing, instead of adding my indices like when I multiply, I do the opposite operation. So when I divide, a quick way, instead of having to expand it and do this whole la-di-da and count them off, is just if the bases are the same, I can subtract the indices. Okay, let's have a look. Simplify giving your answer in index form. Index form simply means that I'm giving my answer in the base form. Now, simplify giving your answer in index form. This is saying 3 to the power of 6 times 3 to the power of 4. Okay. I do not multiply my indices. Okay. Another way of writing 3 to the power of 6 times 3 to the power of 4 is 3 to the power of 10. Okay. I do not multiply my numbers. Do not multiply your numbers here. Simply give them as the same base and only add the indices. So what I did there is I went, okay, 6 plus 4 equals 10, 3 to the power of 10. This next one looks a little bit more tricky. It's actually not. All I need to do is it's got x to the power of 3, y to the power of 4, times x to the power of 2, y. Now, there's nothing after this y here. This y appears to not have an indice, but it actually does. It's an indice of 1. Whenever I see something like this, a good thing that I like to do is I always like to add that 1 in on the end, just so I can keep track, okay? So, let's do my x's. X to the power of 3, x to the power of 2. 3 plus 2 becomes x to the power of 5. Y to the power of 4, y to the power of 1 becomes y to the power of 5. So that's x to the power of 5 times y to the power of 5. That's my answer for that one there. This one here, my bases are different, okay? My numbers, my bases here, 3 and 2, these numbers are separate. They're separate from the thing that holds the indice. Okay, so the first thing I need to do is multiply my numbers, okay? Because the indices don't belong to the numbers, the indices belong to the m's. So to the power of 4 and to the power of 5 belongs to the m's. So unlike in that first question, okay, we have to multiply our numbers now. So 3 times 2 is 6. M to the power of 4 times m to the power of 9, m to the power of 5 becomes m to the power of 9. Okay, so the thing that you have to remember here with this one, if my numbers are my bases, it stays the same. If my numbers aren't my base and they're separate, I then multiply them together. Okay, let's have a look at this one. Simplify giving your answer in index form. Again, this is another division. So always rewrite it. That's the first thing I do. X to the power of 10 divided by x to the power of 2. Now, I learnt from index law that I can write 10 x's and I can do a line, and I can write 2 x's on the bottom and I can slowly cancel it out. Or the simple way is I can go the top minus the bottom. I can actually subtract them. So if I've got 10 x's on the top and 2 on the bottom, that leaves me with x to the power of 8 on 1, because I would have cancelled the 2 on the bottom, and then 2 off 10 is 8, which I just write as x to the power of 8. You don't even have to write it in this step, but I'm just doing it so it makes sense to you. This second one here, b, is kind of really important, okay? Now, in this case, okay, I'm looking to simplify. I ask myself, is there a number? First I deal with my numbers, then I deal with the pronumerals. So let's look at the number. Is there a number that goes into 8 that also goes into 12? Okay, so 2 does. Yep, 2 works. 4 does. 4 goes into 8. 4 goes into 12 as well. Good. 8 doesn't go in. Okay, so it's going to be 4. I'm trying to find a common number that goes into the top and the bottom. 4 goes into 8 twice and goes into 12. 4 goes into 12 3 times. Okay, now if I've got a to the power of 6, a to the power of 2, there's 2 a's on the bottom. I can get rid of both of those, which leaves me with 4 a's on the top. Okay, now if I have 2 b's on the bottom and 3 b's on the top, if I cancel out 2 of the b's and I cancel out 2 of the b's from the top, that leaves me with b to the power of 1. Making sure that if there's only one of a pronumeral left, it's a good idea to write it as b to the power of 1 to start with, but then make sure you get rid of that 1. And just to keep this fraction looking pretty, I'm going to write this 3 in the middle. Okay, so the answer for this question here for b is 2a to the power of 4b divided by 3. Okay, this last one is a little bit tricky. It's going to combine some of what we've learned, okay, and group it together. Now, this says x to the power of 2 times x to the power of 3 divided by 4. As soon as you see this division line, this is where it cuts. This is why we always have to rewrite it. Anything after that division goes on the bottom, anything before goes on the top. X to the power of 4 goes on the bottom, which means x to the power of 2 times x to the power of 3 goes on the top. Now, before I can do anything, that's saying everything on the top divided by what's on the bottom. I have to work out that top line. X to the power of 2 times x to the power of 3. I use my index law and I know that that's x to the power of 5. Divided by x to the power of 4, okay? So I have combined these ones by going 2 plus 3. getting x to the power of 5. If I have 5x's on the top and 4x's on the bottom, I cancel them out. It becomes x to the power of 1, which I make sure I write simply as x. This last example here, this is a tricky one, okay? Like I said, the first thing I have to do is the top. It actually looks complicated. I'm just going to rub this one out, guys. It looks complicated. It's actually super easy, okay? I just have to take it one step at a time. The main advice I would give you is deal with your numbers first. So this crazy thing first says 2a to the power of 3b times 8a to the power of 2b to the power of 3. And you think, oh gosh, I can't do it. Actually not too hard. Let's deal with our numbers first. 2 times 8, 2 8s, 16. Okay. Let's deal with the first pronumeral a. A to the power of 3 times a to the power of 2. Use my index law to simplify that to a to the power of 5. Now I've only got one b. Always write a 1 in there to help remind you. Okay. So that's b to the power of 1 times b to the power of 3. That becomes b to the power of 4. Then I divide it by 4a to the power of 4, b to the power of 2. Cool. Now it looks like something I've seen. Okay, now I can actually do something. Let's have a look. Is there a number that goes into 4 that also goes into 16? Of course there is. And I'm going to rewrite underneath, okay? So, the number that goes into 4 that also goes into 16, I'm just going to jump down here. Sorry if it's a bit hard to see. The number's 4. I mean, 2 goes into it, but you'd have to simplify multiple times in order to get the answer. 4 goes into 16 4 times and into 4 once, okay? So I don't have to write my 1 down the bottom, okay? 8, if I've got, I can if you want, but I don't need to. If I've got 5 A's on the top and 4 A's on the bottom, it's going to leave me with 1 A on the top, and I can write a little 1 in there just for the time being. That's not a big deal. If I've got 4 B's on the top and 2 on the bottom, I can cross out the 2 on the bottom, okay, but that leaves me with only 2 on the top, okay, and remember all of that would be over 1. Now, that's fine and dandy to keep that way, okay, that's all right. That leaves me with, let's write this in the best form because, I mean, it's correct what I've got, but it's not in the best way. Instead of writing 4a to the power of 1, I'm just going to write 4a and then b2. So a few steps, sorry, that's a 2. A few steps to do there, guys. The main thing is it's not actually hard, it looks tricky, but just making sure you rewrite it and you simplify correctly. And that's it. That's dividing and multiplying with indices.